Welcome back. In this video, we're going to talk about some network terminology that you need to be familiar with. So, first off, what is a LAN? A LAN is a local area network. That could be in a building, it's across my office with all the computers I have here, and my kids can plug in, my kids have wireless access. So our house is basically a local area network. Colleges have what's called, or high schools, or even middle schools or elementary schools have what's called CANs, or campus area networks. Okay? And that's basically a series of smaller LANs that are connected through a bridge or a router to build a larger network that is for the same purpose, students. Okay? So that's just another term they use for campus area network. So that's a type of network. You have PANs. This one I got kind of a kick out of when I saw it. It's a relatively new term. It's a personal area network. And this refers to, I'm working on a laptop and my phone is connected to the laptop and my AirPods are connected to the network and my watch is connected via Bluetooth. So I've got 4 or 5 devices that are all connected to the same laptop that's doing a lot of stuff for me and alerting my calendar and uploading music to my watch, whatever it is. You can now legitimately say you're a walking network. So you're a personal area network. Okay? A WAN. A WAN is a wide area network. The way I think about this is Comcast, to me, because we have Comcast coming into our house, that's a wide area network. And when all of the neighbors shut down for COVID-19 and everybody started binge watching Netflix, the network slowed down. Okay? So it's a wide area and there's a lot of people using it. So a wide area network is what a WAN is. A MAN is a metro area network. These are typically located downtown in a particular town or city, and it's often run for residents of the city or businesses in the city, but it's in an urban area, sometimes where buildings are a problem, and so they set up network equipment to make it higher speed, especially for businesses and companies, but that's a metro area network. Okay. And by the way, don't be fooled on an assessment if I ask you what an FAN is, a fan. A fan is something you plug into the wall to keep you cool. Okay? It's a fun distractor I use once in a while. And I get like 2 people every year on that one. All right. Network interface card. I showed you a picture of this in the last video. Basically, it's hardware that connects a computer to the network. Modern times, your phone, that's going to use a Wi-Fi signal anyway, but your computers, your laptops, if you can plug an RJ45 into it, it's built into the motherboard. Okay? Now, MAC address. This is your media access control address. This is like a social security number for a piece of hardware. It is not changeable. It's typically burned in to a chip on that device so that it doesn't change. Okay? This is why you need to be aware that committing electronic crimes is inherently stupid. Because if they can access the MAC address of the device, they know which one it is. It is a unique identifier for a given circuit board. Okay? And anything that can connect to a network has a MAC address. And it is unique to that item. Okay? An IP address. This is your internet protocol address. This is the mailbox of your router or the device that you're using. The reason I say router is, as I mentioned in the earlier video, I have an external IP address to the internet, which is my router's IP address. Internally, every device I have in here has its own IP address on my local area network. Okay? But that's the mailbox that all of the packets coming to my device are dumped. So if it's the mailbox of my router, it's going to get a bunch of packets for a bunch of different devices. And using the switch in the back of it, it's going to farm out the packets to the appropriate device using the internal mailboxes of the internal IP address. Okay, there are two protocols, not four, hint for tests. An IPv4, or the Internet Protocol version 4, had a 32-bit address space, okay, which meant 2 to the 32 is how many addresses you could have. We're running out of addresses. That's a lot of addresses, but the world is running out of addresses because there are billions of devices connected to the internet now, okay? I mean, we've got refrigerators connected to the internet to tell you how many eggs you need to buy on the way home, if not placing the order for you, okay? So we're running out of addresses. So they've upgraded that to IPv6, which was supposed to replace IPv4. It is there with IPv4, but IPv4 is going to be around for a while, okay? So you should have two versions of an IP address on most devices. But you get 128 bits, which is a whole lot more numbers of addresses, okay? So instead of going 32, well, let's just double it. They said, let's have some room to grow. And they went all the way out to 128 bits. Much, much better. Okay? Now, network interface. The thing I showed you was a network interface card. That's the hardware. Network interface refers to the software that either runs on that card, is the firmware that I showed you in the prom, or is also burned into the motherboard, or is part of the operating system that basically connects to the device to the internet. It does that by going out and requesting an IP address. We'll talk about that in a minute. Okay, a wireless access point. This is where if I was in my lab at school, I would point to a thing hanging on the ceiling. Right? It's about that big, and it looks like a little router or switch. But basically it's called a WAP, a wireless access point. And it allows a bunch of computers to connect to the network via that thing. And it has its own connection back to another switch, which is connected to another switch, which is connected to another switch, which is connected to the routers that create our campus area network. So a WAP is a wireless access point. It's basically a wireless switch. Okay, network standards. In order to create the internet, we had to have standards that everybody follows. An easy example of a standard is driving on the right side of the road, or if you're in Great Britain, the left side of the road. Whichever side of the road your country drives on, that's a standard. You could violate it, but you wouldn't go very far. Okay? So standards help everybody play under the same rules of the road, so to speak. And with the internet, that's critical. So we have network standards. Network security is software, and when that software is burned into firmware or onto chips or loaded when you're running, if it's a host-based firewall, that security software basically tries to prevent unauthorized access to any of the resources on your system, whether it's printers, whether it's access to your files, it doesn't matter. The network security software is to authorize and prevent unauthorized access to whatever the resources are. Your network address is an identifier for your node on the network, and it needs to be unique. That's why we use IP addresses, okay? And there are two ways to get an IP address. And when you control your switch or your router, you can configure it to dynamically assign IP addresses through what's called a Dhcp Server program. Okay, it serves IP addresses so that when you connect a new device or your buddy comes over and fires up his laptop and finds your network, his network interface card, his network interface software will ask for an IP address. And then the router or the switch will give him an IP address. Okay? Now he's got his own address. He goes home, it's gone. He comes back, opens it up, it might be different the next day. Turns his computer off, it might be different. Sometimes devices, like if you have a printer or something that sometimes older hardware, that you have to reconfigure it somehow if it loses its IP address that it's talking on. You can have the router or whatever is running the software to dynamically allocate the IP addresses. You can say, when this MAC address asks for an IP address, always give it 192.168.1.114. Always give that to it. Okay? That's called a static IP address. So you can give a static IP address, so when that device tries to join the network, it's always getting the same one. But normally what we do is you get a dynamic IP address. And it's only good for the state of while that connection is going. Okay? Now, the definition of being connected to the internet means that you have an IP address that is accessible from the internet. Okay? So if you fire up your browser at home and it says, cannot connect to DHCP server, you now know what it means. You're not connected to the internet. You need to go look at the router because it's probably got flashing error lights or no lights or one that's doing the slow pulse of death instead of doing the frequent flash that it's getting packets. Okay? So the definition of am I connected to the internet means I have an internet protocol address that is successfully sending and receiving packets on the internet. Okay? All right, network diagnostics. These are just tools. Software that tells me what's going on my network. I know our county has people that monitor this software 24 hours a day, just in case students are trying to hack into their grades. Okay? And these diagnostics can set all kinds of alerts. They can record things that are happening. Network diagnostics is a whole branch of security software that has companies competing in that space. There's some really cool software out there that does diagnostics. It creates visuals of where your traffic's coming from. If you've ever watched a spy movie where they've got all this, here's an attack. Some of it's fake, but more and more, it's not. There's visualizations of where are your threats coming from, right? So diagnostic software for networks is a very big business. Okay, in the next video, we're going to talk about topology and what that basically means for networking. See you on the other side. Welcome back. In this video, we're going to talk about network topology. And rather than belabor this point, I'm going to jump right in with the topologies, and it's going to make a lot more sense. So for networks, there's really two distinctions that we need to make. Because when we talk about topology, it can get confusing at first if you don't have these two different definitions down. So the first one is a physical network. This is literally how we plug the hardware in, how it's connected. So my desktop has an RJ45 cable. This particular Surface Pro and my cell phone and my iPads are all connected wirelessly. Okay? How they're connected is the physical network. How the data flows from a given device to a particular switch to a particular switch to the router out to the internet is the logical network. Okay? And so we're going to talk about the topologies of logical networks and how it's done. So I'm going to briefly talk about what they are, then I'm going to show you a picture because show and tell is a lot easier to remember. Okay? So a bus. When you hear the term bus, unless you're an electrical engineer, you're thinking large yellow rectangle that moves kids to school. That's not what we're talking about. When we say bus, we mean long wire or cable. Okay? So a bus network, everybody's grabbing onto the cable at a certain point. Okay? A ring. Right? This is the one network ring to rule them all. Okay? And a ring is common in fiber. It's a circle. Everybody's grabbing onto the circle at some point. Star. This is not like the 5-point star. This is switch in the middle, and they're all connected out like this. So it's one cable run to each unit. And then you have mesh or full mesh, where literally every computer is connected to every other computer. Okay? And we're going to talk about these, but basically the first three are single point of failure. You can, if the line breaks on any of these, you're done. Okay? Full mesh, because everyone's connected to everyone, you always have a path. So if one particular connection goes down, you've got redundancy so the information can move. Full meshes are used in very important government systems, very important medical systems, in hospitals and some of the high technology where you can't suddenly lose data. If you're talking about what they're advancing with modern surgeries, remote surgery, they're talking about using robots 200 miles away to perform surgery from a surgeon that's 2 states over. You get into stuff like that, you better have a mesh network, because if one of the lines goes down, you don't want the robot to go, oh, sorry, I can't finish the surgery. Okay? So mesh networks are for high redundancy. They're also extremely expensive because you have to have a lot of physical hardware connections. Okay? Now, for a mesh, if you want to know, and my students need to know this, how many connections do I need? You take the number of computers or devices that you want to connect to the mesh, and you so let's say that's n, so let's say it's 5, okay? So 5 times 5 minus 1, which is 4, so that would be 5 times 4 is 20, divided by 2, that means I would need 10 connections, okay? So if it's 6, it would be 6 times 5, right? N times n minus 1. 6 times 5 is 30, divided by 2 is 15, okay? So as you can see, you get up to 100 computers, you need a lot of connections to build a mesh, okay? So they are very expensive, but you have all kinds of redundancy. So let's look at these individually, kind of graphically. That's a bus. That's all it is, okay? Ethernet tends to be a bus network, okay? Unless you mesh the Ethernet. But basically, that's a bus, okay? A ring, back when Ethernet was getting its start, they had this thing called token ring. They even had token bus at one point. But what it was token ring, there was this virtual ring, if you will. And if you've ever been in a group where they had a talking stick and you couldn't talk unless you were holding the talking stick, if you had the ring, you could broadcast to the network and receive packets. And you were allowed to hold the ring for a certain split second of time, then you had to pass it to the next thing. So the ring went around and around, kind of like an old distributor cap if you ever worked on classic cars. And that's how it worked. And it competed with Ethernet, but Ethernet turned out to be a lot cheaper. And with Ethernet, basically you broadcast the network, and if there's a collision of packets, both devices wait a random amount of time and try again. So there's a lot of collisions, but it works, and it was faster and cheaper to build. So that's a ring, token bus. In a token bus, the ring just went back and forth, okay? Star network. Notice, here's a switch, and everything's connected that way through the star, okay? This thing goes down, everybody's out of luck. And a mesh, this is a little hard to see, but all these black lines, each computer is connected to each other computer. So I can break this line and I can still get to the other computers. Okay? All right. That's all we need to talk about for topologies, because like I said, I just want you to be aware of what they are and what the differences are. Make sure you understand the difference between the physical network and the logical network, how the data flows. So in the next video, we're going to unpack the OSI model for the internet, which is basically how the internet works. So I'll see you on the other side.